All right, welcome to this explainer where we are going to absolutely demystify SQL. Today, we're not just doing dry theory. Actually, scratch that. We're doing zero dry theory. We're going to act as digital architects and build a fully functional, secure student database literally from the ground up. Whether you've never written a line of code or you just want a quick, structured refresher, this is exactly where you need to be.
So, here is our game plan. First, setting up your server. Second, building the database foundation. Third, populating the student records. And finally, querying and sorting data. Let's just dive right in.
Section 1. Setting up your server.
Right, so before we build our digital house, we've got to prep the land. Our land here is an Ubuntu server, and these 5 sequential commands are going to be your best friends. First, update the package index with sudo apt update. Second, actually install the software using sudo apt install MySQL server. Third, verify it's running with sudo systemctl status MySQL. If it happens to be asleep, step 4 wakes it up with sudo systemctl start mysql.service. And finally, log in with sudo MySQL. Simple, sequential, and honestly, super effective.
Now, what's really fascinating here is the whole concept of root. Root is basically the master user account. It holds the absolute highest level of system privileges. By using that sudo command, it temporarily gives us these root superpowers. It proves to the system, hey, we have the authority to safely build, tweak, or even tear down this database architecture.
Section 2. Building the database foundation.
Okay, server's prepped, so let's pour the concrete. We use 2 really straightforward commands here. First, create database studentdb. That literally commands the system to construct a fresh, empty database. But creating it isn't enough. You got to step inside it. That's what use studentdb does. It's like telling the server, hey, all the work I'm about to do, put it right here in this specific database. Inside this database, we're going to build a table. Think of it like a highly organized, supercharged spreadsheet. We'll call ours the students table, and we're setting it up with 5 specific columns: student ID, name, age, department, and marks. The absolute most crucial piece of that puzzle is the student ID. This is what we call our primary key. It's a unique identifier for every single record. Look, if you have 2 students named Amit and they're both 20 years old, the database has to be able to tell them apart. The primary key is your ironclad guarantee that no 2 entries are ever confused. And here is the exact SQL blueprint to physically build that architecture. We type create table students, open up our parentheses, and just list out our columns. Student ID is an integer, that's the int, and it's our primary key. Then name is a variable character string up to 50 characters, age is an integer, department is a character string, and marks is an integer. It's so logical, right? It almost reads like plain English. Section 3, populating the student records. The foundation is set, the walls are up, so let's move the furniture in. To get data into our new table, we use the insert into command. We say insert into students, values, and then, matching the exact order of the columns we just set up, we drop in our data. So for example, we insert 101 for the ID, Amit for the name, 20 for his age, computer for the department, and 85 for his marks. You just load it row by row. And honestly, this is the incredibly satisfying part. If we repeat that command a few times, our totally empty table is suddenly this beautifully organized structure. We've got Amit in computer with an 85, Priya in IT scoring a 90, Rahul in mechanical with a 75, Sneha in computer with an 88, and Neha over in civil with a 92. It is clean, it's structured, and it is totally ready to go.
Section 4. Querying and sorting data.
Right, so a database is pretty much useless if you can't get insights out of it, isn't it? We don't store data just to hoard it. We store it to ask it questions. The most basic tool for this is the select star command. That little asterisk, it's a wildcard. It just grabs and displays absolutely everything in the table, every single column, every row. It gives you the entire board at a glance. But, what if our table had 100 columns or 1,000? We definitely don't want to see all that noise at once. What if we only care about the student's name and their final marks, and we want to completely ignore the ID, the age, the whole shebang? Well, it's really easy. We just swap out that asterisk for the exact column names we want. By typing select name marks from students, we tell the system to only fetch those 2 specific things. Boom. Your data retrieval is instantly precise and uncluttered. Okay, let's step it up a notch. filtering columns is cool, but what about filtering rows? How do we ask a highly specific question like, hey, who are the students exclusively in the computer department? This is where SQL really flexes its muscles. We bring in the where clause. By running select star from students where department equals computer, that clause acts like a strict bouncer at the door. It scans every row, but only lets through the ones where the department perfectly matches the word computer. So in our setup, it instantly hands us Amit and Sneha.
And the where clause isn't just for exact text matches either. It is absolutely amazing with math. So what if we wanted to identify our top performers? Let's say anyone's scoring strictly above an 80. We use the exact same concept, just with mathematical operators. We run select star from students, where marks is greater than 80. With that one tiny line of code, any score 80 or below, like Rahul's 75, is literally instantly filtered out. Finally, let's talk presentation, because how data looks matters. To automatically rank our students, we just tack on order by to the very end of our query. You can effortlessly flip between an ascending list, lowest to highest, with order by marks ASC, or descending, highest to lowest, with order by marks DESC. It is honestly that simple. Okay, just take a second to step back and look at what you've learned today, with literally just 5 foundational commands: create, insert, select, where, and order by. We took an empty Ubuntu server, secured it, and built a robust, totally searchable data structure. And it's pretty incredible to think about, but the massive tech platforms you use every single day, social networks processing millions of posts, banks moving money around the globe, they all rely on variations of these exact same building blocks. You've got the blueprint now, so the only question left is, what digital world are you going to build next?